Hello, my Facebook students. Today we are going to review exponent rules on problem solved. Okay, hello Anastasia. If you are waving to me, I will not probably be able to see you all until after I take a little break from the rules, but I want to make sure I come back on and review the exponent rules. I had someone in the comment to suggest that I go over the exponent rules. All right, so good afternoon, my Facebook students. I hope you all are healthy and well, and I hope you have your pencil and paper out and ready to take notes and replay it if you need to review it over and over again until you have these exponent rules remembered, because you will need them for pre-algebra, algebra 1, college algebra. Okay, so let's get started. I hope I have more students to come on later or replay it later, so this will help them. All right, so let's get started. Had to work out today to make sure I keep my soul, mind, and body in shape. So sometimes I may start a little later, or I may start another day because I am pursuing my PhD. So sometimes I have to take a break and focus on that. But I am coming back to you with problem solved on exponent rules. All right, so hello, let's get started. All right, I'm going to erase this. This was just an introduction, but I'm going to erase this so I can go over each exponent rule. All right, so hopefully this will only be a 20-minute, maybe 30-minute session regarding our exponent rule. So any variable that starts where you'll have it with your alphabets from A to the letter Z can be used as your base, or you will see it in algebra or algebraic problems or expressions. All right, so this is called a variable. So sometimes you'll see A through the letter or to the letter using Z. But the most popular variables are X, Y, and Z. Those are your most popular variables that they like to use in the textbook. All right, so any base that's raised to an exponent or a power, if it's raised to zero power, so anything that's raised to zero power is equal to 1. Okay, so A raised to the zero power is equal to 1. Doesn't matter if it's this, if it's A, if it's B, C, D, or if it's Z. If it's raised to the zero power, it is equal to 1. All right? So I'm going to erase this because I'm going to need my board, pretty much everything, my space on my board. All right? So you have your base, and you have it raised to an exponent or power, and your variable could be A through any letter to Z. All righty? And the most popular variables are X, Y, and Z that you'll see normally in a textbook. All right? They love to use X and Y. Okay, so let me erase my vocabulary, terminology. I'm big on vocabulary because your answers are always in your vocabulary or definition. Your definition of an exponent, if you know the definition of an exponent, your answer is within the definition. So definitions are very, very important. Rules, formulas, you need to know those. All right, so let's go back here. So A raised to the zero power is equal to 1. All right, so let's just do an example so we can see it with a number. So if I have 2 raised to the zero power, it is also equal to 1. Okay? If I have 757 raised to the zero power, it also is equal to 1. If I have y raised to the 0 power, it's 1. Okay, if I have the letter z, variable z raised to the 0 power is 1. So the concept is if anything, any variable or number is raised to the 0 power, it is equal to 1. All right? So that is the first exponent rule that you need to know. All right? So I'm going to erase this. This is a number 2, not z. My z's I will represent like this, so you'll know the difference. My z's would be up. See if I can write that correctly. My z will look like this, and this is a number 2. So you would know the difference if I ever use the letter z and I use the number 2. Okay. So that is the first rule, and I'm just going to put this over to the side. So a to the 0 power is equal to 1. That's the first one. Now, let's go to our second. Let's just put number 1. So let's review the second rule. The second rule is if I have a raised to the negative 1 power equal, what is that equal? So since this is a negative, you cannot have a negative as your exponent. You have to convert it and take the reciprocal. So this is really like saying a to the negative 1 is all of this is divided by 1. So what we're going to do here is we're going to do something called the flip or the reverse or the reciprocal of it. So what's the reciprocal of a to the first power? It is 1 with a to the positive first power. Okay? And in algebra, we drop the 1 because it's understood. So we're going to rewrite it, and it's going to be 1 divided by a. Okay? So we drop this 1 because it's understood in algebra that a variable that doesn't have an exponent is always raised to the first power or to the number 1. Alrighty? Yes. Okay. So now let's do an example with substituting the variable with a number. So let's use 3. So if I have 3 raised to the negative first power, it is going to be the reciprocal, okay? I'm going to just write that reciprocal. Reciprocal. I'm big on words because they're definitions, okay? So you'll understand the meaning of it. So 3 raised to the negative 1 is 1 over 3 to the positive first power, which is only 1/3. 1 over 3. All right? So let's change this and let's make this a negative 2. So let's do 3 raised to the negative 2. Trying to do different colors so you can see each concept behind it. Raised to the negative, 2. Let's raise it to the negative 2. All right. So what would that be? That would be 1 divided by 3 raised to the positive 2. So this negative becomes a positive. So we can't leave it like this, okay? Because this is not the final result. So let's just complete the calculation. So 1 over 3, 2 raised to the second power means you multiply that same number that's given to you by how many times it tells you. So we need 2 of our 3's. So 1 divided by 3 times 3. And what is 3 times 3? 3 times 3 is 9. So that is 1/9. So it's 1 divided by 9 or 1/9. Okay? So this is our second exponent rule that you must know. All right? I hope you have your pen and paper because I have to erase today because we have several exponent rules that you need to understand. You need to know these. Okay? My last session, I did the FOIL method, and then we factored the trinomial, and we had a to the second or a to the first, and we had to multiply those. You have to know the rules when you're multiplying exponents. So now we're going to go to the third rule, all right? Hello, Stacy. Hello, Marcia. Hello, Valerie. I appreciate you all watching. I hope you're learning from this. And if you are, and you feel that it's beneficial to other students, please don't forget to like and share. All right, moving right along. All right, so going to our third rule. So I'm going to list them over here. So this is our second. This is our second rule, which is a to the negative first power, which is the reciprocal of 1 over a. Don't want to be sloppy here. So 1 over a to the first power, which is saying 1 over a. All right, so this is our second one. So now we're going to go to our third rule. All right, our third rule is 1 divided by a to the negative 1. Okay? Now, you see where we did the reciprocal here? All we have to do, if we know this rule, all we have to do is just take the flip of it, or the reciprocal. So that means we're going to bring a in the numerator, a to the first power, divided by 1. All right? So it's understood in algebra that if we have 1, we can drop it, and also if it's divided over 1 or divided by 1, we can drop that 1 too. So it'll just be a over 1, which is just saying a. Okay? Because a raised to the first power is just itself. So this is our third rule. Okay, let's move on to the fourth rule. So I'm going to erase this, and I hope you have this in your notes. All right? So I'm just going to erase this, and I'm going to keep it just like this. But remember, in algebra, anything raised to the first power is always itself. So let's do an example with a number so you can better understand this. So let's just go over here, and I'll have to erase it. So let's just do 1 divided by... we're just going to do, let's use, I like 3. So let's use 3 raised to the first power. So all we're going to do is flip it, take the reciprocal, which is over 1, but we can drop that. We don't need that because it's understood. But for the rule's sake, we're going to keep 3 to the first power there, just for the rule's sake, okay? Now I'm going to do it with 1 over 2 to the negative 2. So we're going to take the reciprocal or the reverse, and we're going to bring this in the numerator. That's going to change to positive. Remember, this changes to a positive, and it's over 1. But we don't need it because it's understood in algebra. So this is saying 2 times 2 over 1, which is 4. 4 over 1. And any whole number that's over 1, it's just a whole number. 4 divided by 1 is just 4. Okay? If you were to do it the long division way, 1 into 4, 1 times 4 is just 4. You subtract it. So you don't need to put a remainder. Alright? It's just itself. So 4 divided by 1 is 4. Alright? So this is an example for we have our powers as negative and we have more than the number 1. Alrighty? So what if we had, I'm going to erase this, what if we had, because my board is going to get tight. So I'm just going to come up here and just do another example. What if we had 1 over 4 to the negative 2? That would be that would be 4 squared, or 4 raised to the positive 2. And then that's 4 times 4 over 1, which is 16 divided by 1, which is equal to 16. Okay? All right. All right, so let's erase this. So this is our third exponent rule. All right, so let's erase this. I hope you're taking notes or you replay this later and review it. You have children that's doing this, reviewing this right now, or have this as an assignment. Then this would be good for them to have. All right, let's go to the fourth rule. And the fourth rule is what I used yesterday, I believe, or the day before yesterday in my session in factoring trinomials. All right, so if we have a raised to, I'm just going to use a letter right now, a raised to the r power times a raised to the s. And I'm going to do an example. And remember, when you have two variables next door to each other, that means multiplication. So this could be a dot, or it could be a x, or you can have two sets of parentheses next door. All right, so you can have a dot for multiplication. You can have the letter, well, we represent timetables with x, or you can use two parentheses next door to each other. All right, so if I had a to the r here times a to the s, that's what that means. Okay, so anytime that you are multiplying your r and s, your exponents, you must add them. All right, so I'm going to rewrite it. So that's a raised to the r plus s. So that's saying a, and then if you're multiplying your variables with your exponents, you add them. Okay, so let's do an example of our fourth rule. So here's our example, okay? Getting tongue twisted today. Okay, so let's do, if we have a raised to the second times a raised to the third power, we must add our exponents. So that is a 2 plus 3, and 2 plus 3 is equal to 5. So now we add our exponents, and that will be a to the 5th power. All right? Now I'm only doing an example with the variables here. Now let's use numbers. All right, so let's do 2 raised to the 2nd power times, now I'm going to have to put it in parentheses, because when you have numbers, it will look very confusing. So I'm going to use parentheses. Like I said, we can use parentheses here. So let's do 2 raised to the 2nd power and 3 raised to the 3rd power. Hope you all can see the board. Hope everything is clear. All right. So now remember, this is our base, 2 is our base, 3 is a base, and 2 here is your exponent here, and 3 is your exponent here. So that means we have to take 2, let me go back. You need both of these as your base. So like we have, here we have a and a, they are the same. They are the same, so we can add the exponents. So we must have the numbers here as the same base, so we can make sure we're following the same rule. All right. So now I'm going to take 2. 2 is our base, and now 2 plus 3. We must add our exponents. All right. 2 plus 3 is equal to 5. So remember, your base must be the same so you can add those. I mean, you don't have to have. All right, Jack. All right, so let me repeat. 2 is your base. This is called your base. They must be the same so we can add, so we can follow this rule as a to the 2nd power times a to the 3rd power. We must add our exponents, okay? So this is the base and this is the base. And remember, 2 and 3 are your exponents. So now we have 2 raised to the 5th power. All right? Now, if they want you to keep it like this, you can. But sometimes when you're online, they want you to give the final result, the final answer. So what does 2 raised to the 5th power means? It means that you're going to take 2 times 2 times 2 times 2. How many? 1, 2, 3, 4, and 5. So that means you have to multiply 2 5 times. So let's do that. And some students get this confused. So this is what I like to do is say, take 2 and go put an arrow here. 2 times 2 is 4. Then 4 times 2 is 8. 8 times 2 is 16. And 16 times 2, I believe, is 32, if I got it right. Let me check. 16 times 2. 2 times 6 is 12. And we cross multiply. 2 times 1 is 2. Plus 1 is 3. So that's 32. So 2 raised to the 5th power is equal to 32. All right? That's how you do that if you're using numbers. I hope you all can see it. Sometimes my window, the glare is here, so that's why I'm repeating. All right, so 2 raised to the 5th power is equal to 32. And how do we do that? We count. We have to multiply 2 5 times. 1, 2, 3, 4, and 5. And we break it down saying 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And 16 times 2 is 32. All right, so that is the 4th rule. When you are multiplying exponents, that means with the variable and the exponent, you must add them. Okay? These are the exponent rules that you must know before you really get into multiplying binomials, trinomials. When you're using a distributive property and you have variables raised to an exponent, you have to know these rules. If you don't, you will get the answers wrong. This is one of the basic concepts that you need to know. All right, I'm going to erase this and I'm going to the 5th rule. All right. All right, so what is the 5th rule? The 5th rule applies to division. This is the 5th rule. And the 5th rule is if I have a raised to the r, I'm going to use variables right now, divided by a raised to the s. When we have division, we must subtract. So that's saying we use the same variable because we have a and a, so we're using the same variable. They have to have the same variables. Same variables or same base. Remember, this is our base. Let me kind of remind us, this is our base here. A is your base, and 0 is your exponent. So we must have, I want to speak in the right terms, we must have the same base. And then the exponents, when you're using division, you subtract. So that'll be r minus s. A to the r minus s. So when you have division, let me just put that in the same color. So it's r minus s. So when you have division, you subtract the exponents. So let's do an example. All right, so let's use, this is my example. So you'll have everything in your notes. Okay, so what if we say a raised to the 3rd power divided by a raised to the, I guess I must use 2 because if I can use 1. Let's just use 1 so we can see the number. I want to make sure it comes out kind of evenly. All right, so we have a raised to the 3rd power divided by a raised to the 1st power. So we have to subtract 3 minus 1 is equal to what? 2. All right, so this will equal to a squared or a raised to the 2nd power because we had to subtract 3 minus 1. You subtract your exponents. Okay, give me a few minutes. The music is too loud. Hold for a second.
And they got all dressed up too.
All right, hope you had a few minutes to digest that concept. Okay, so let's now substitute where the variable a's are. Let's just use numbers. So let's take let's take 4 raised to the 6th power divided by 4 raised to the 2nd power. All right? So we have the same base, which is 4. Now we have to subtract 6 minus 1, and 6 minus 1 is 5. So it would be 4 to the 5th power. Now, on some online assignments or in your textbook, if you're working problems out like this, they may ask you to either leave it like this or give me the final answer. They want the number. So what would be the number? That means we have to multiply 4 5 times. 4 times 4 times 4 times 4. I don't know if I can squeeze it here, okay? So this is 4 times 4 times 4 times 4 times 4. 1, 2, 3, 4, 5. That's 5 times. All right, maybe I should have made my numbers a little smaller here so I can, because that's going to be a very large number. So the first thing you want to do is say 4 times 4 is 16. 16 times 4. Then whatever that answer is times 4. Then whatever that answer is, okay? I would have to pull out my calculator. I could do it the long ways. Okay, so what is that answer? 4 to the 5th power. Let's see, 4 times 4 times 4 times 4. Let's see, 1, 2, 3, 4. One more, times 4. And my calculator says the answer is, so if you multiply and you put it in your calculator, it will be 1,024. So 1024 or 1,024 would be your answer for this problem. All right. So this is the this is the 5th rule. All righty. So we did it with the variable and we did it with the number. So let's move on to the 6th exponent rule. It takes time to understand these rules. I always suggest the students please write it down, create a chart in your notebook, so if you need to go back and review, you will have it. All right, so your 6th exponent rule is for when you have it outside. So we have a raised to the r power, and then on the outside it's raised to the s power. This can get a little tricky, but just follow me and put it in your notes, write it in your notes. So when we have an exponent on the outside of an exponent, we have to multiply, all right? So that means I'm going to say A R times S. Let me put that in a different color. R, I'm going to use a dot for multiplication, R times S. And in the textbook, it's written like this, so you'll see it. It's always written like A-R-S. That means multiplication, all right? I just put a dot there so you can see that. In my textbook, they don't put a dot. In the text viewing, if you can see, I'm just reviewing the exponent rules, okay? But I'm breaking it down so you will understand it. Because sometimes we get lost when we're reading a textbook, especially a math textbook. If you don't read it thoroughly and understand what it's saying, you can get lost. Students can get lost. All right, so now let's use an example. So now we're going to use an example, okay? Let's write example so we'll know the difference. We're going to do an example now. All right. So let's take A and let's represent as, let me just use Y. Let's use Y raised to the 2nd power. And then we're going to raise it to the 3rd power. All right? So this time we're using, instead of A, we're using a different variable. Let's use Y since it's so popular. I should have used X, but I didn't. I just took from the textbook. Okay? So that is equal to Y 2 times 3. That means we have to multiply, right? We can use a dot or we can use an X. And 2 times 3 is 6. So when we rewrite it, it's Y to the 6th power. y to the 6th power. So when you see it like this, you have a variable raised to a double exponent, you must multiply those two exponents. That is the 6th rule. Now I'm going to erase this and let's use a number this time. Let's replace y with the number. All right, let's just replace y with the number. Let me erase this so we can.
It's pretty easy.
Okay, so what number? Let's use an easy number because the larger the number, the larger your result is or will be. All right, so we have 2 raised to the 2nd power raised to the 3rd. So that means we're going to take 2 and we have to multiply. 2 times 3 equals 6. So that is 2 raised to the 6th power. And remember, that means you have to multiply 2 6 times. 2 times 2 times 2 times 2 times 2. Let's see, 1, 2, 3, 4, 5, 6. So that means you do 2 times 2 is 4, 4 times 2. You know, I'm not going to go back through that, but that's what you do. You do 2 times 2 is 4, then you take the next answer and multiply it, and you keep multiplying. So let me see what that answer is in my calculator. Let me clear. So we're doing 2 times 2. And if you have a scientific calculator or a Casio or graphing calculator, you can just put it in 2 raised to the 6th power and it'll give you the answer right then, okay? So I'm just going to tell you what that is. 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 6. So the answer for that is 64. So 2 raised to the 6th power is 64. All right? So this is our 6th exponent rule. When you have your power raised to another power, you must multiply the exponents. All righty? Okay, moving right along. I know it takes time. I'm hoping to do just 30 minutes today, but sometimes the rules, we have 3 more rules to go. All right, and this will be your full exponent rules. So let's erase this. So now we're on exponent rule number 7. So you can create a chart with this and it'll help you so you'll have it somewhere in your notes. All right, the next one is if we have, let's make our parentheses here, if we have A and B and we have it raised to an exponent, or I'm using a letter here. So that means we have to break it up. Remember, this means multiplication, A times B, but everything that's in here, you have to raise it to that power. So A to the R times B to the R. Okay? So that's separate. A raised to the R, B raised to the R. And you leave it just like that. Because A and B are 2 different variables and you cannot multiply those. You leave it alone. You let it remain that way. All right? So let's use a number. Let's just try. I just want to show you several ways. Let's use 2. So if we have A and B, this will be A raised to the 2nd power, B raised to the 2nd power. Okay? Now let's just put in numbers. Let's try that, okay? So let's just use, I'm going to erase this because I want you all to see it. So I need to erase this and give it to you with the numbers. All right? So let's substitute our variables, which are our letters, in numbers. So let's do 2 and 3 raised to the 2nd power. Remember, this is kind of like multiplication. If you have numbers, okay, I'm gonna show you how you do that. But we just have 2 different numbers, but normally we have 2 different variables here, okay? So let's just move on. So we have 2 raised to the 2nd power times 3 raised to the 2nd power. Now in this example, you can get a final answer because you're not using variables. You're using numbers, and with numbers you can always come out with another number. So let's do that. Let's shift it over here. Let me shift my equal symbol over here so we have some room. So we have 2 raised to the second power means that we say 2 times 2, and I'll put it in parentheses so we can separate it, times 3 times 3. Because 3 raised to the second power is 3 times 3, right? So 2 times 2 is 4, times 3 times 3 is 9, and 4 times 9 is equal to 36. All right. If this is helping you, please like and share if you're watching, or you can replay it. And when you replay it, don't forget to like and share. I am reviewing the exponent rules. All right, we have 2 more to go. All right, so that was rule number 7. So let me erase this. I hope you're taking notes, or you can replay it and review it over and over again. All right, so I'm going to erase this. All right, I'm going to shift this over a little bit. So this is ARS here. That means you're adding here. Okay. R plus S. All right, so now we're at the 8th rule. We have 1 more after this. Okay, so the 8th exponent rule is if you have A divided by B, and it's in parentheses, and you raise it to the R. So now if you are catching on to the pattern, you would have A to the R divided by B to the R. Okay? So let's just put some numbers in there, and you can see how to do that. So let's say we have 2 divided by 3 raised to the R power. Then you're going to have, well, we don't want to do R. Let's do a number. Let's do 2. So we would have 2 raised to the second power divided by 3 raised to the second power, which that would be 2 times 2 is 4, and 3 times 3 is 9. That would be 4/9. Or you can reduce it. That's going back to reducing fractions. That's why when I started these sessions, I reviewed reducing or simplifying fractions. So this is where okay, when we reduce 4/9, that's going to be, well, we can't reduce 4/9 because we have an even and an odd, okay? But you can always check to see if you can reduce. So since we can't use the same multiplication factor for 4 and 9, we must leave it here at the final answer of 4/9. All right? Okay, now we're on our last exponent rule. Yes, yes. Okay, I'm going to erase this, and I have to squeeze the 9th and last rule for the exponent rule of today. Okay, so I'm going to erase this. And I'm going to have to erase and put the 9th rule. Let me just erase the exponent rules here, because I hope you all can see this. I'm going to the 9th rule, so I have to erase this. Okay, the 9th rule is if we have A divided by B, and we have it in parentheses raised to a negative exponent. And remember when I talked about doing a reciprocal here? It's the same thing, except we have it inside of a parentheses, and we need to flip it or take the reciprocal of it. I'm going to put it down here. So that would be B now is in your numerator, A is in your denominator. Okay? And we're going to raise it to the R power. So the negative R went to a positive R. This is our 9th exponent rule. Okay? So let me put an example here, and we will be finished with our exponent rules. Okay? So let's do 2 divided by 3. And we're going to raise it to the second power. Okay? So, what do we need to do? We need to take the reciprocal of it. So that means your 3 is now going to be in your numerator. Your 2 is in the denominator. And we still raise it to the second power. So that's saying 3 squared divided by 2 squared. Okay? And 3 squared is saying 3 times 3, which is 9. And 2 squared is saying 2 times 2, which is 4. So the answer or the result is 9/4. Okay? So if you understand your exponent rules, when you're going further into your algebra and you come across where you have to multiply, divide, using multiplication and division, and the major one, a lot of students forget that anything that's raised to a 0 power, any number, any variable, it will always be number 1. It would be 1. Okay? So I hope you all like and share if you believe this would be beneficial to any other students out there in Facebook land, or if it's a great review for yourself to help your children that are taking algebra. This is a very important rule to know. Okay? So let me just step back, make sure I covered everything. 1, 2, 3, 4, 5, 6, 7, 8, 9. Did I miss a rule? Think I did everything. Okay, I think I covered everything. If I missed anything, I will make sure I come back, and if it's a rule that I missed, hopefully I didn't. And this will be a great review for you all. All right, this was problem solved today. I hope you learned something. I hope it was a great review. Please stay healthy and safe. Work out. Take care of your soul, mind, and body. Pray and replay, like, and share. Hello, Valerie, if you're still there. Alrighty. Thank you for watching Problem Solve on reviewing exponent rules. And don't forget to like and share.